Hi, I'm Catherine Plaisant.
And I'm Tom Bruns.
We are from the Human-Computer Interaction Lab of the University of Maryland. We will present a prototype of a user interface for NASA's EOSDIS project.
EOSDIS is the information management component of the Earth observing system. It will collect data from a variety of platforms and store the data sets in designated archive centers. Data users will browse, request, and download data sets over computer networks.
The current prototype offered by NASA is a classic form fill-in interface. Relatively complex queries are possible, but it is difficult to avoid the zero-hit problem or even estimate how much is available.
To facilitate querying and browsing, we extended our dynamic query interfaces to take into account the new challenges of EOSDIS.
Our early dynamic queries prototypes have shown that novices or expert users could rapidly query databases, explore trends, and find exceptions. But those prototypes used only a few thousand records, all in local storage, while EOSDIS implies more attributes and more records which are distributed on the network.
To keep real-time interaction under those conditions, we propose a two-step approach.
In the first phase, called Query Preview, users query all data sets by specifying rough ranges over only a few attributes. Here we see three attributes: geographic location, parameter, and time. Preview bars show the number of data sets available for each attribute value. We can see that there are many data sets for North America and not as many for the Atlantic. More vegetation data sets than precipitation data sets. Note that the numbers used in this demo are not real. When a user makes a selection, for example, selecting North America, the preview bars change to reflect the number of data sets that still satisfy the query. We now see the distribution of data sets for North America. The result bar at the bottom of the screen shows the number of data sets selected. 766 data sets is too much to download, so the bar appears red.
This approach relies on the data centers maintaining these counts of data sets which are downloaded when the user initiates an EOSDIS session.
In a similar manner, we can choose parameters, for example, vegetation and land classification, and choose some years where data is available. There are no more zero-hit queries, since we can see what data is available. With a few selections, we have quickly filtered out the bulk of the data sets. The total number selected is 66. We are now ready to proceed to the second phase of the query. The metadata of the 66 data sets is downloaded from the data archives.
In the query refinement panel, we see the 66 data sets and their coverage over the years we had selected, from 86 to 88. The y-axis spreads data sets by size, the large data sets and the small ones. Color indicates the processing level of the data, from raw to highly processed data. All attributes of the metadata can be selected for display, and finer selections can be made. We can ask to see only data sets having data from the NOAA satellite and remove the raw data sets. Every selection updates the other controls to show the valid combinations.
When a data set is selected, the spatial extent is shown on the map, the attribute values are highlighted, and the record is shown in the table. Before the long process of ordering actual data, users can view image samples of the selected data set.
The two-step approach extends the use of dynamic queries to network environments. It was well received by test users from the scientific community.
We are continuing our prototyping effort in Java and exploring other applications to large managed collections.
Thank you.